Okay, in this lab, we're going to do some gravimetric analysis. It's a little different from your lab book, although they have good examples of the calculations for standard deviation in your lab book under Lab 8. But this is a handout. We're going to work with Tums and generic tablets. The title is Gravimetric Analysis. It's a type of quantitative analysis because we're quantifying mass. So when you do that, it's called gravimetric analysis. So in Tums tablets or generic tablets, we have the active ingredient calcium carbonate, or also in those tablets you have fillers, dyes and sugars. So all that is in each tablet in different amounts from different companies. The reaction that we're going to do is we're going to take the calcium carbonate tablet and add some hydrochloric acid. Similar to the hydrochloric acid that's in your stomach, the reason you take the Tums is to relieve a stomach ache. Same type of reaction occurs in your stomach. The products are calcium chloride, H2CO3, which breaks down immediately to H2O, which is a liquid, and CO2, which is a gas. During this reaction, the tablets are going to gas off. You're going to lose mass of that gas. And so we reweigh and we find the mass lost. So you're going to have to show your work, the dimensional analysis and the stoichiometry. You're going to find the grams of CO2, that's your mass loss. We're going to take that CO2 and change that to moles. Then we're going to use this molar relationship, 1 CO2 to 1 CaCO3. And we're going to change the moles of CO2 to moles of CaCO3 using the stoichiometry. Once you get the moles of CaCO3, you can use the molar mass or the molecular weight and change the moles of CaCO3 to grams of CaCO3. Okay, anytime you do an experiment like this, the name of the game is to label everything. So I'm going to have Tums. I'm going to have 3 beakers. I labeled my beakers T1, T2, T3. I even labeled my tablets so I don't confuse when I'm weighing. We're going to take the generics. We have generic 1, generic 2, generic 3, generic tablet 1, 2, and 3. The first step we're going to do is to individually weigh each tablet. So let's start doing that. All right, so Tums 1 tablet weighs 2.405 grams. Tums 2 tablet weighs 2.587 grams. And Tums 3 tablet weighs 2.680 grams. All right, done with the Tums. Now we're going to weigh the generic tablets. So generic 1, 2.310 grams. Second generic 1, 2.303 grams. And the last, or the third generic Tums, 2.252 grams. All right, so the weight of these individual tabs are just for question number 4 at the back of your handout. That's it. The next step is to add 25 mils of acid and 25 mils of distilled water to each beaker. So let's do the water first. Perfect. Adjust it with a pipette. Good. Good. All right, we added all the water. Now we're going to add 25 mils of the acid to each beaker. Perfect, Barbara. It's done, so we know that. Put it back. Do the same with the generic, 25 mils of acid to each beaker. Right. Now we're going to weigh each beaker with the tablet next to it. So we'll take our beaker with our water and acid Tums tablet, number 1. The tablet next to it. So the weight together is 120.059 grams. And we could put the tablet in each beaker as we go along. So one is going in one. The second Tums is 128.119 grams. Plop, plop, fizz, fizz. And the third Tums is 122.001 grams. Add the tablet. And then we'll do our generic. $120.600 grams for the first generic. Drop the tablet in. The second one. $120.426 grams. And the last one of the generic. $118.300 grams. Okay, we'll drop the tablet in. And now we have to wait for all the CO2 gas to evolve. All right, well, it looks like all of our tablets dissolved and the CO2 gas is gone. So we're going to reweigh each flask and we'll get the mass of the CO2 by difference. All right, let's go. All right, Tums 1 is 119.485 grams. Tums 2, 127.578 grams. Tums 3, 121.483 grams. All right, on to the generic. Generic 1, 119.952 grams. Generic 2, 119.846 grams. And the last generic, number 3, 117.724 grams. All right, and now we could take a look at our calculations. All right, we have all of our calculations. We have all of our numbers for your data sheet. I'm just going to show you an example of how to do standard deviation. We've already done average deviation in a previous lab. Now we're going to do standard deviation. So these are only examples. We did 3 samples of each so we could generate deviations because we're going to use some statistics for quality control, which you would use in a real lab. So let's just say I had these 3 samples and I had these 3 weights, 1.01 grams, 1.00 grams, 0.99 grams. I add it up, I get 3 grams, I divide by my 3 samples, I get an average of 1.00 grams. In statistics, the average is the mean. Then I take my mean and subtract each one of my samples from the mean. It's an absolute value, so they're positive. This is my first one, my second one, my third one, and these are my deviations from the mean. The equation for standard deviation, which you can find in Lab 8 in your lab book, SD, or standard deviation, is the sum of the deviation squared over n minus 1, all under the square root. N equals the number of samples. You had 3 samples for Tums. 3 minus 1 is 2. Easy enough. Do the same thing for the generic and get the standard deviation. And the report value should be your mean plus or minus 1 standard deviation. The difference between average deviation and standard deviation, average deviation is for when you only do a few samples. So really we could use average deviation for this, but we want to show you how to do standard deviation. In a production lab, you may have 500 samples you're doing for the day. Then you would generate statistics using standard deviation.